Today I want to add support for graphical applications in Plum. So adding a way to render stuff to the screen and receive keyboard inputs or something like that. Yeah, I don't really have a plan on how to do that. So let's just brainstorm, I guess. First of all, the main function currently returns a task. I think that's a bit limiting because it can be one of these things. What we really want is for the environment to be able to control the program, I think. The kind of the VM that hosts this program should be able to ask the program to render something of a certain dimension, so that you can resize the window and the program renders something appropriate to the size. So there needs to be a way of kind of communicating that information to the program and rendering that on demand. I don't want the program itself to have this sort of core render loop inside it, that decides now we are handling user input, now we are rendering stuff, now we are reacting to window resize events or something. I want that to stay outside of this main program within the VM. And then the VM can ask this program to render a single frame given a size, something like that. So I think let's not say this returns a task, but rather let's say this returns an app, like a graphical application, whatever that's gonna be. So this will be stuff that allows the environment to give input events and so on to the program. So I think it's going to be a struct with a couple functions so that the environment can choose which function to call, which lambda to call. So this will have a render function that receives something and returns some sort of texture, I guess. Yeah, later on, this will also have like a handle input function maybe, or handle event or something, where you can, where the app can basically react to keyboard presses and so on. But for now, actually, I think just having a render function is fine. And in here we pass in a size, the size of the window, and then we get like a texture of that size that kind of contains the pixel data. Which leads to the question, what is the size? What is the texture? I think this is more than, I don't want to leave that in the playground. I think next to the standard library, the core library, I'll actually add a graphics library maybe. And this contains definitions for like texture and size and the colors probably, stuff like that. Yeah, for now it's just a single file, which means, actually let's not have that be implemented as a folder, but rather as a single file, which is similar. It's like the workspace graphics module. Whether that's a folder or a single file doesn't really make a difference. But in here we define our texture as something. We define colors probably. We define the size. Yeah, something like that. So let's see. Size is just a width and a height. So this is a struct with a width and a height, both of which are integers. Yeah, they can't be negative. There are some invariants that are not encoded in types. So what? And the texture is, I think, a matrix of colors. Do we have matrix in here? We do. Okay, so we do have matrix T as a type, which has basically a size, and then a number of cells, which is an array. Okay. It doesn't have code for accessing an element at a position. It's kind of weird. There's a quite unfinished type. I'll have to change that. All right, so we have size. We have textures, which is just a matrix of colors, so a two-dimensional array basically. And then what's the color? Color, I think, is something with red, blue, and green. Actually, I think these are going to be bytes. Like, typically these go, from 0 to 255 inclusive. So this is the way that colors are usually represented. Oh, I may want to allow here transparency. Which is usually called alpha. Does that make sense? Yeah, I think so. Yeah, so a texture can also have transparent patches in there, which I guess that makes sense. Okay. Pretty cool. Okay, I have size, I have color, I have a texture. And then in the playground, hang on, we need to import stuff. Well, yeah, the compiler is going to tell us, I believe. So in here, we're not just going to import core, but also graphics, and in particular size, texture, and color. And that an app is just a struct with a render function. I'm not sure what to do with tasks, because this is clearly a useful model for like console apps and stuff. I think I'm just going to leave that in here for now, and come back to that when, well, at some point in time. All right, so then the main function is going to return like a graphical app. And let's remove the higher lower game, that you can use to like guess numbers. And instead, let's say we just want to fill the screen with red, maybe. That's simple. That would be generate matrix. Hang on. That's a struct with a render function that then accepts the size and returns a texture by calling generate matrix of a width and height. Could put size in here. Maybe. No, something like that. I think that makes sense. So we'll put the size in, we put that in here. All right. So then, yeah, we call generate matrix with a size, and then a function that's gonna be called for with two integers x and y. And it returns a color, with red being 255, or the byte of that. So 2 byte, does that exist? Red, green, which is 0, and blue, which is going to be 0, and then finally alpha, which is going to be 255, which means like fully visible. And let's maybe simplify that a bit, and this one breaking that on multiple lines. Yeah. All right, I like that. Cool. Then, what else? I think we need to import stuff here. So let's do that quickly. Importing bytes and matrix. And I think that's it for now. And then let's try to compile that and see where things fall apart, which I'm pretty sure they will at some, like somewhere. I just don't know where. So run playground. Okay, in here. Oh, I see. So this is supposed to be like that, right? Yeah. Try to use matrix with one argument, but it needs to, oh yeah, it's matrix of some type T. I don't know. Yeah, graphics doesn't have the concept of size. Oh, I see, and we don't, yeah, the core library doesn't export size yet. So let's change that. Let's say that in here from the matrix module, which is LM in here. Yeah, we actually also import the size, which means we can then call that, okay, 2 byte. I think that's in here. There is, hang on, 2 int of a byte and the lower byte of an int. Lower byte, yeah, hang on. Let's maybe add a 2 byte as well. That takes an int, returns a byte, and that also asserts that the byte is, you know, that the int is within the range that the byte can represent. So int has to be bigger than, bigger or equal to that. Setting that that's the case, and that, like that, yeah, sure. And that the int is less than 256. Yeah, and then int dot lower byte. Right, and we do need to export that here. Byte, lower byte to int to byte of an int. Okay, and then in the playground we can import that to byte of an int. Alright, then generate matrix. It takes a size and int to t. First something with a width and height, and then something that takes an int and another int and returns a color. Oh yeah, that's meh. And generate matrix. Hang on, yeah, we do want to call this one. Oh, I think in here I kind of fucked up. Yeah, this is supposed to be the size. Alright. Then in the byte we do import, you know, greater equal function for ints and less than for ints. And okay, slowly we are getting there. Assert, which comes from check or test or something. Test. That's a compiler internal error. Okay, sure. Stuff to debug. Fun, fun, fun. Yeah, right. Okay. Here, copy from stack. With a builder and then a start and a size. Yeah, here we assert that the start plus size, that makes sense. All right. Yeah, and here we only want to copy 8 from the stack if the stack is aligned to 8 bytes. So, yeah. Hang on, if the start plus the cursor is a multiple of 8 and the builder stack size is a multiple of 8. then we push singular bytes in here. I'm copying this byte by byte. So push 1 from stack, start plus cursor. Yeah. Actually, I think I can unify these, so like this. That's it. And all. Nice series, by the way. Yeah, that's kind of what I'm going for. Yeah, if we can copy 8 bytes at once, aka the source and destinations are aligned to 8 bytes, and we want to copy at least 8 bytes, then we do that. Otherwise, we don't. That makes sense. Fixing the bytecode generation, which is like completely unrelated to what I actually wanted to do. But that's how it goes. You jump into these unrelated rabbit holes, kind of, and still the same error. Well, lower byte. Interesting. Lower byte. Yeah. When we want to execute a lower byte instruction, the stack has to be aligned to 8 bytes. So, where do we call that? In compile expression, in waffle to ground in here. Okay, so we have call indirect, which we have the stack aligned to 8 bytes. So this I see there's not even emitting a lower byte instruction, it's just something else. We have this one. Yeah, okay, so this is the place where that falls apart. I think we need to emit padding, so build a line to 8 bytes. Then we compile the argument to this, then we get the lower byte. And then we do build up top below top. Below the top byte, we push we put the padding that we just added.
Okay. Yeah, that makes sense.
Because the ZigVM assumes that the program returns a task, but it doesn't. It returns an app, which you can use to render stuff. In theory, you can't do that yet, but yeah. Okay, so let's commit that still. Like the thing about, here we go. Yeah, aligning the stack. Align the stack. Cool. So this doesn't work because we assume that the program returns an app, which it doesn't. That's something that I need to fix in the VM though. So in this file. Hang on, actually no, in this file, where we assume that this is a program that returns a task. Where in reality the program returns an app. A graphical app, which doesn't exist. We need to make the Zig, the outermost Zig VM, we need to make that understand the app type. So let's add that maybe below the task, not entirely sure. Okay, so app is going to be a struct. And I'll just, keep this very strict, like very similar to these other data structures, like a string, for example. I'm just going to copy that and then adjust that. So an app has a lambda for rendering. Yeah, it has a lambda that is lambda from size to texture. That's it. I mean, of course, that doesn't exist, but we'll figure that out. Actually, let's create that as well. So, that's going to be similar to these other lambdas, I believe, because lambdas have a uniform representation. So lambda from size to texture. You can create that from bytes, you can convert that to bytes, alright, you can call that. Not with a string though, but with a size, which also doesn't exist. Yeah. And then we have this texture that it returns. Alright. So what is size? What is texture? We'll need to define these first. Actually, let's do that before the task, maybe, or I don't know. Yeah, let's define them here. So size is just a struct with a width and height, both of which are integers. And then you can do stuff with that. You can create a size from bytes where you need 16 bytes. Oh, and I think the way that works is Now these are sorted alphabetically, so the size comes first, 0 to 8, like that. And then the width is going to be from 8 to 16. Cool. Then turning that to bytes is, well, something like this, joining things. Oh yeah, this is size. Converting a size to bytes returns size dot first the height, then the width. Let's call it self. Sure. Okay, and that returns 16 bytes. Yeah, we don't need that. Cool. I think that's actually everything you need for size. Then color. And it's going to be similar. Oh, it doesn't have dupe and drop, but that's fine because it doesn't contain any pointers. So you would never need that. Yeah, a color has red, green, and blue, and all of which are bytes. Also alpha. Byte isn't a thing, but it should be similar to ints. So byte, creating that from bytes, or from a single byte, is just going to return that byte, like so. Converting that to bytes is just that. All right. I mean, yeah, let's also do that. Sure. Cool. So we have a notion of bytes. Hang on, in array of bytes, we just use those. Maybe that's cleaner. I don't know. Okay, so we have a task, we have several lambdas, we have the size, we have the color with bytes. Alright, so let's sort these alphabetically. Red, green, blue, and alpha. That means that this entire thing is going to be 4 bytes. Oh man. Yeah. This one's going to go from 0 to 1. This one from 1 to 2, 2 to 3, and 3 to 4. Alright. Oh, that is ridiculous, actually. Yeah, let's remove that. Sure. Let's remove bytes in favor of just using U8. I think that's totally fair. Yes, we can't do this. And it's not super consistent with the rest, but I mean, come on. We can just do this. That's way cleaner. Alright, and then 2 bytes. That's gonna return self dot buffer, self dot blue, self dot green, and self dot red in an array, which is gonna be an array of 4 bytes. Alright. So we have colors. What else? Textures. That's a struct with a size and a matrix. Actually, let's define our type matrix of color. I mean, actually, let's not. Let's just do it like this. And rather than cells, let's call that pixels. That makes sense. And that's nope. Yeah, that's an array of colors. Yeah. How's array of bytes defined? We need that same thing, but for colors. Oh man. Oh no. That requires a buffer of colors. So we do need a buffer of colors as well. Oh man. Okay. And then this one is has a pointer. Might actually be easier to write generic zig structs for that. You know, like buffer that takes a type. Yeah, I think that makes sense. yeah. Okay, that's kind of... But then it also makes sense to have bytes as a type here. Okay, let's do that. Sure. Let's... I feel like I'm going back and forth here. So creating a byte from bytes. Sure. That's just gonna be a single byte that is inside. And every one of these types has a size, so that's going to be 1. It has an alignment. Yeah, and that's it. Yeah, I know. Hang on. These don't have to be uppercase. Yeah, okay. Mm-hmm. Even better, let's define layout. Yeah. Make something with a size. Can we do that? And an alignment. And then for these, let's just say layout is like so. Mm-hmm. Cool. And then we have ints with a size of 8 and alignment of 8. And we can just do this. Mm-hmm. Clean. Yeah, pointers, let's not add that for pointers. Let's not add that for buffer of bytes, because these are kind of internal types. These are not really Plum types that Plum code can access. Yeah. Let's also not make this pub. I think that's cool. Need this one. Yeah, now we're talking. Yeah, buffer of bytes, and then here's array. These kind of all, they all belong together. All right. So buffer of bytes rather than that. I think this should be a function buffer that takes an item type and that returns a type. And this doesn't need to be annotated, I know. And it returns a struct. Here we can just do that. That simplifies things a bit. All right. And similar for the array. This will just be a function that takes an item type and returns a type. And it returns this sort of struct. And this is going to be a buffer of that same item type. Clean. All right, yeah. And this also has a layout. With a size of 24 and an alignment of 8. These are fixed. Clean. Alright, we're slowly but surely getting somewhere. Yeah, this run right here returns an item. Yeah, and of course the buffer returns the item as well. Because it takes the... Oh yeah, I also need to fix these. Yeah, dupe is correct, but in here if the ref count is 0, then pointer from int. I think let's inline these into just array and have all the complexity in one class instead of splitting that up into 3 different ones. I think that makes things a bit easier. Yeah, if we just say this is a usize, you know, and then this from bytes, actually, you know, that's just this one. Boom. Yeah, and converting these 2 bytes is just that. Yeah, no need for this kind of pointer thing. But then also the buffer itself, I think we can inline that in the array. And make the array contain, yeah, a buffer of items, but really that's just a pointer, right? Like a buffer pointer. Instead of this. Yeah, and then here the buffer pointer is just something. It's this one. Standard mem. Oh, it's just that. From bytes 0 to 8. Nice. That's this one. Then converting things to bytes. Yeah, let's add a function usize to bytes or something like that. It's kind of weird, but Alright, so this is just usize from bytes 0 to 8. Yeah, nice. And this is self.buffer pointer and usize 2 bytes of self.buffer. buffer pointer. Clean. And this calls itself.buffer.dupe, but that just increments the ref count. So let's do that directly. So that would be self.bufferPointer dot. That's it. Self.bufferPointer. All right, and then dropping the ref count is similar. It requires an allocator actually. Interesting. So what we do is we do self.bufferPointer. It's the ref count. If it's 0, then we read the length, which is the buffer pointer plus 8. We get the pointer, which is self.buffer pointer, and we know that this pointer has 16 plus the length bytes in there. Yeah. We don't need to free the individual items though, so from 0 to len, we actually do self.get I dot drop using the allocator. Nice. That is cool. And then this get function finally is basically just this. We call self.bufferGet with that, and that's kind of the, raw index. We convert that to a usize so that we can then unconvert that back to a raw index. That doesn't make sense. Times item.layout.sprite-size. Oh, I like that. Nice. Yeah, and then this is just an array of bytes. Yeah, okay, so we have bytes, which here let's say this is a layout. Let's make that better typed, and let's add a sprite size function. Yeah, sure, let's turn those into usizes, and the sprite size is just think that's the way to round up. Not entirely sure though. All right. Cool. And then this is just hang on, we have arrays, we have strings. Okay, yeah, and then we have the lambda, which just has pointers here. That does seem reasonable. Okay. Yeah, I don't know. I guess that's fun. And then instead of these, like buffer of colors and array of colors and so on, in here we can just say, well, actually let's create a type matrix that takes an item type and returns a new type. And that actually returns a struct with a size and cells, which is going to be an array of that item type. And the layout is going to be, well, 16 bytes plus 24 bytes. I'm tired, okay. It's okay if that takes a little bit of time for me to think about. Yeah, and we do have from bytes and 2 bytes for that. Oh, I see. This is a function that returns that. Makes sense. Okay, creating a matrix from 40 bytes, just actually the cells come first in the memory layout, so the cells would be the first 24 bytes. Something like that, and the size would be size from bytes 24 to 40, like so. And then in here we just do the opposite. We do self dot cells, self being self. Alright, cool. We can also dupe and drop stuff, so let's add functions for that. Dupe, I mean the size doesn't need to be duped, doesn't contain anything useful. The cells, they might, so we do self.cells.dupe. Yeah. Drop with an allocator does self.cells.drop. Oh, actually that might require the bytecode. Does it? Well, for now, not really yet. Yeah, might have to fix that later. Okay, and then in here, this is texture is just a matrix of colors. Nice. Yeah, and you can create that by by saying let's return something with pixels being a matrix of color from these bytes. And if you want to convert that to bytes, you just do self.pixels 2 bytes. Clean. Alright, then our lambda from a size to a texture is actually a lambda. That makes sense. An untyped lambda. And you can hang on. Can we? I think I'll add a lambda. Yeah, I think I'm gonna rename lambda to untyped lambda. Like generic lambda, something like that. Yeah. Yeah, and then I'm gonna add a version of that called, lambda with an input and an output. It's gonna be a function, and that just returns a struct similar to this one. Actually, do I need the untyped version? Maybe I don't. Maybe I don't. I think I can just take this entire thing and plop that in here. Clean, and return that. That's nice, because then in here I can add a call function like this one. Nice. That takes this lambda and then an input, and it produces an output. Like so. Yeah, and here we have the unused parameter. Alright. Yeah, that was a lambda from nothing to something. Let's instead look at this one and see what this does. Yeah, this is a bit closer to what we need, I think. Yeah, we convert the input to bytes plus the lambda closure. And then we convert the typed output. Nice. Yeah. And then this is just lambda nothing task. Oh yeah, true. Yeah. That's quite cool. Yeah, no, we don't need these ones. Or this one, or this one. Nope. Because it all composes quite well. That's cool. Here we have color. Yeah. What's going on here? This is lambda nothing to task, lambda int to task, lambda string to task. Alright. And then down here we generated texture. Hang on, lambda from size to texture, we don't need that. We can just turn that into a lambda from size to texture. Okay. Oh yeah, this is nice. Output bytes and output. I think I'm gonna steal that for the lambda as well. So in the lambda, these will be the output bytes, and this is the typed output. Let's see, this won't work. Like the question is where are the compiler errors, you know. So in 417, here we take output bytes. Ah yeah, those have to be 24 bytes, that makes sense. And I could also say this needs to be app.size length. Plum.app has no member named size. It doesn't, that's true. But it does have a layout. I hope it does. It doesn't. Okay, so let's add that. It does have a layout, which is a layout with a size of 24 and an alignment of 8. Oh, hang on, in the main file. Yeah, we can't switch on that because that's actually just an app. And now instead of this loop, let's try to do something with that app. Yeah, we don't need randomness for now. Let's do Alright, so this doesn't work apparently. I was quite sure this was the way to do that. Is it like that? No.
I don't know.
Is it just that? That's it, okay. Stem it in, we don't use that apparently, sure. That compiles, that's surprising. I mean, Zig is quite lazy, so it probably doesn't even analyze most of the code. Okay, so here things go wrong already. Do something with the app. Okay, so we do have an app with a render thing, which is a lambda from size to texture. And well, it contains, you know, a few pointers to the bytecode and the heap. Cool. So, what do we do now? Actually, I guess the first step would be to render something graphical, just, you know, disregarding Plum for a moment, just rendering something in Zig. I think I'm going to use Raylib for that, just because I have used that before at some point. So let me pull up a browser. Can't zoom the UI itself. I want to search for Zig Raylib. I don't know. There are bound to be some tutorials or something. So manually treat auto-generated Raylib bindings for Zig. Okay. This does seem reasonable. Tested on Raylib version something and Zig something. Do I have? And there are probably. Okay, I mean, we have an existing project. Cool. Oh, that's... You can do that. Interesting. Did not know that. Let's just do that. Raylib Zig. Does seem to be reasonably popular, so... Oh. Yeah, that's not an error, that's fine. Alright, then add Raylib Zig as a dependency and import its modules and artifact in your build.zig. Alright, so in my build.zig, which is here. Oh, actually, let's have a look in this. Did this change? Yeah, there is a Raylib now. Oh, I like that. With a hash and everything. Okay, that's cool. Yeah, let's add this one. So this is just standard options for something. And then, boom, we have a Raylib dependency. Raylib, RayGUI, and Raylib artifact. And then we do this. We create an executable. We do that. Okay. Yeah, that's... I hope I don't need to tweak that. Alright, and then we should be able to do this. I am curious whether that works. Like I've tried this back when, you know, Zig wasn't even at 0.14 or what it is right now. Whether you didn't have the Zig zon file and the build process was different and stuff. So let's see if that compiles. Oh, hang on, that's not what I wanted to do. This is the one. Okay, it does fetch. It checks out some packages. And it compiles the Raylib stuff, I guess. Oh, hang on, but it's still compiling the build script. Oh, and now it's compiling Raylib. That seems fine. Unexpected LLD standard error. What's going on? Do I need to install Raylib, maybe? Like something like that. Yeah, I guess let's go to here and see if there is. Okay, I do have GCC and Git. Oh, that's the one, isn't it? Oh man. Sure. Does this work now? It did something better, I guess. And when I run this, okay, it still crashes. That's, I mean, you know, we leak memory, so that's expected. Okay, but now let's have a look at the example here. I don't even know what's going on here. Let's copy that in here. I'll just see what's going on. So we say the screen width is 800, screen height is something, and then we init a window. Then close the window. Oh no, we defer that. Let's see. We set the target FPS. While we shouldn't close, we clear the background in white and we draw text. Okay, and then after we should close, whatever that means, we exit this loop and do the actual stuff. I'm curious if this works. Also, let's check. Okay, MIT license. That's fine. And Raylib itself also. Zlib. What is that? Okay. Yeah, there's like a copy left. What are the two kinds? Well, similar to the MIT license. In the spirit, you know. All right. Oh, hang on. Actually, I mean, yeah, no. That's altered versions don't have to be. Yeah, don't have to be published. Yeah, so it's like MIT. Anyways, okay, let's see. Hey, this didn't do anything. Right, because I need to compile that. And that errors. Unexpected LLD standard error. What even is this? Oh yeah, I'm still on X11, by the way. Maybe I could change that to see if that fixes anything. Okay, that doesn't... Okay, what in general, unexpected LED standard error. Warning. LD is our linker apparently. So we are linking libraylib.a. What is etrel? Is that some sort of bytecode thing? Oh, it's like an elf type binary relocatable. Okay, I guess. I mean, that's just weird. Just want to have Raylib working. Actually, you know what? Let's look at Martinez, my previous language. Oh no, hang on. The bytecode soil, and see how the ZigVM handles Raylib. Like this is using an outdated Zig version, so I'm not actually sure. Oh yeah, I did update that to the zig.zon file. Raylib zig from notnick. Okay, so I'm using that version. Fair enough. So in here I do these sort of things. Raylib dep is Raylib minus zig. Let's see if that kind of matches. Yeah. Then we have Raylib GUI, Raylib artifact. Okay, so the GUI is something I don't use in here for some reason. Okay, and then I'll link the artifact and I add an import. Yeah, okay. I know that this worked at some point, so how does that still work? Can I like go into that? Can I hang on, soil zig probably? Yeah, and then just do a zig build. Okay, I can't. Yeah. Yeah, like zig is pre-alpha, there were breaking changes, and this was written for some previous zig version. Yeah, which means that this is kind of left on my own here, I believe. I mean, this has to be an error that other people have as well, right? Nope, not the error, not the error. These are not even my errors. Oh, well that's similar to what I'm doing. Raylib zig stuff. Where is that? Where can I do that? Yeah, that's... think from zig 13 to 14 something's changed. Why don't these things just work? You know what, let's try that. Let's do, so when you say dependency, you want to put that in there. Alright, let's try that. So, for the zig dependency, we want to use x11 as a backend, which is not, you know, nice or perfect, but hopefully it works. Let me double check that I'm using that. Yeah. Like, I like programming, but this is the kind of stuff that I just can't, you know, dependency management is such a mess, apparently. Yeah, I mean, this doesn't really work, I think. I could check out Raylib itself, not the zig version, and see if that, you know, if that fixes anything. Although there is nothing about how to install that. Do you just download C and header file and stuff, and that's it? That's like, everything about that feels ugly. Installing and building Raylib. Alright, so GNU Linux. Oh, that was this one, right? Yeah. Visual Studio. Okay. I mean, pre-make 5. Arcane cryptic commands that you have to execute. Everything about that is horrible. Everything. Okay. Options. I mean, I guess in the long term it makes sense for me to switch to Wayland. So I'm gonna do that. Which requires restarting the PC and reconfiguring stuff. So I'm not gonna do that while recording. So see you after that. Okay, I switched to Wayland, updated my graphics card driver, and well, let's do this. That looks way better. We now have debug output, because of course we do. But we also have this nice window that says, congrats, you created your first window. Super cool. Alright, yeah. So now when I close that, yeah, okay, that makes sense. Then we actually execute the bytecode and stuff. Cool. So let's dig into this. We have a screen width and a height. We initialize the window with title Raylib zig something. Okay, no, let's instead use ground, because this is the ground VM. Boom. And then here we I mean, this is not really a game, you know, but sure, let's set a target of 60 frames per second. Here's the main game loop, you know. Okay, and then in here we update stuff, and then we draw stuff to the screen. White with some background. Okay. All right, and now let's merge that kind of into the stuff down here. We have arguments and a file path. All right, we read the bytecode. Makes sense. Then we print running of that bytecode, and then we run that. Actually, that makes sense. Actually, let's do that in here. All right. I think before that we should also start. Create the window, stuff like that. And then this main loop is basically what we want to. Well, we want to do something. Question is, what do we want to do? Okay, so shuffling things around, does that work? Let's test that. Zig build, composite build script. Sure. I mean, this is failure. Build an Excel. Failure. But this still works. It did build something. I see. Okay. Oh, but it looks weird with its own custom taskbar. Was that there before? Was that? No, before that was different, right? Why did that change? Why are we now currently rendering our own taskbar? And this looks wonky. It's like in the. I mean, it's not really super readable on the stream, I guess, on the recording, but this is no longer centered, the text. How did that break things? Oh man, okay, hang on. Oh, let's add that. Linux display backend. Even though we are not using X11. I'm using Wayland, but maybe there's like a compatibility bridge and that makes things different. I don't know. No idea how that stuff works. And now even though it failed, let's still execute that. And now it looks fine again. Okay, I'm not gonna question that. Not questioning that. Okay. Okay, so we can render stuff. That's cool. Then I think what we want to do is we want to call the render function actually. Right? We want to the app has a render function, which is a lambda, which we can call with an input, which is a size. In our case, that could just be, something with the width being the screen width, which is not really a good name for that, but sure. Because my screen width is something different. And the height, okay. We do need the bytecode, I guess, and allocator. Alright, fine. And that returns us a texture, but it may also fail. like so. Okay, and then we don't do anything with that texture. That makes sense. Let's maybe debug print that. To do something with the texture, and then we print the texture. That did not do anything. Let's rebuild that. Expected a plum int, found compile time int. That makes sense. Let's instead do plum dot int dot from usize, I guess. Yeah, and this height is the plum int from usize of the screen height. Okay. So now we're getting to the errors. No field named lambda instruct lambda 245. Oh yeah, this is just self body, right? Yeah. Same here. Okay, usize does not support field access because that's just that. Two bytes. Yeah, I think that's like usize 2 bytes. Like so. Okay, texture is no member named layout. Let's fix that. Here's the texture, and it needs a layout. All right. Then 254. Output dot from bytes. Expected texture font size. So when you have a texture and you call from bytes, it should return you a texture. And similarly, this should return you 40 bytes. Yeah. I'm just gonna ignore that and assume it works. Okay, we'll do something. Do something with the app. Wait, I guess. Oh, hang on, does it actually run code? Does it take this long? Oh no. Oh, it did take that long. Dang. Ooh. Ooh. Yeah, okay. Fine, that's fine. Let's generate a texture that is a bit smaller then. Let's say, what is it currently? 800 times 450. Let's say 100 times 100. Still taking some time. Dang. Yeah, I gotta optimize that. Also profile that. Well, my entire logging shell just crashed and I was logged out. How can that even happen? Honestly, how can a single program break that? That should not be possible. I want a sort of system where that doesn't work without, you know, like containerization of everything, and like just design the system from the ground up in a way that that's not possible. Okay, but this works apparently. Right, so there's a segmentation fault for some reason. That is unfortunate. Okay, so to do something with the texture. And here's our texture. Boom. Alright. Alright. Let's maybe simplify things a bit. Let's say we only want a texture that's 10 times 10 pixels. Oh yeah, we didn't recompile that. Sure. Okay, still segmentation fault. Okay. Let's print the texture in the terminal. Let's say, actually let's say the width is going to be 10, and the height is going to be 10. And then this just uses the width and height converted to ints. And then in here we say for 0 to the height with some y coordinate, we do something, and then for 0 to the width with that x coordinate, we do something. And what we do is we just print let's print the colors, right? So it's like converted. Oh, I think that. Let's do texture dot pixels dot get x and y. That would be in here, and the matrix type. Yeah, we want a function get that takes an x and a y, and it returns an item. And what it does is it just does self.cells. That's an array. And then we get, well, basically x. And how are those sorted again? Let's look in the matrix module. And I think that index I is x modulo something is the x position, and the y position is that divided by something. Okay, so it's height is the major thing. First, all the pixels in the first row, then the second row, etc. Which means that in here we'll do y times the width plus x. And the width is going to be self.size.width, which is an int dot to usize. Like that. Nope. Still need to compile that. Oh yeah, and return that. Okay, unused local constant, that's true. So in the main function, in here, let's say we print the red component of the color. Expected. How do placeholders work again? Color has no member named layout. We can fix that. Let's do that first. So color is this, and this does need a layout with a size which is going to be 4 and an alignment which is going to be 1. Alright, then the stride size up here doesn't really work because we need to return that. Also, let's think through that. Let's say we have something of size 5 but alignment 8. What we want the stride size to be is 8. Basically the size rounded up to a multiple of the alignment. So we take 5, we add 7, 12, dividing that by 8, 1, taking that times 8, yeah, that works. Alright, if you have something of size 8, we add 7, divide by 8, yeah, I think that works. Okay, and then the layout strings. Oh man, arcane strings. There was some sort of doc comment up here. Yeah. Okay, so we can have placeholders of this format. The argument and specifier, okay, yeah, we don't need that. We just have a colon in there, right? Let's move here. We have a here we have a colon, yeah. Then the fill character, a single Unicode code point, used to pad the formatted text. That's going to be a 0 in our case. That's correct. Then the alignment, yeah, aligning to the right, making the number right aligned, filling with zeros in front of that, up to a width of 2. Yeah, and we don't have precision. Oh, we do need the dot, right? Oh, that's kind of weird, I think. Oh, hang on, what's the specifier? Oh, I think that's the X actually. Yeah, okay. So the X has to go before colon, that's it. Invalid form string X for a byte. Yeah, because this is that. Okay, it builds. That's cool. And here we go. That is some sort of texture. Cool. Now let's do that in a readable way by also printing new lines after every line, and by printing spaces after these, like so. I don't know, I need to rebuild that, then run that. Yeah, those are the red channels of our image. let's actually do that for all colors. Let's print the color. So this would include red, green, and blue. Alright. Right. Rebuilding that, first of all. And then rerunning that. Boom. Yeah. That's pretty cool. Yeah, let's just take a look at the Plum code that generates that, the playground thing. Yeah, here we generate a bunch of red pixels. And that's exactly what you can see here. We have a texture that is just red pixels. That's actually pretty cool.
Alright. Let's do,
I don't even know, x plus or x times 10. Dot lower byte. And for the green component, let's take the y thing. And that should give us some sort of gradient. Yes, lower byte in scope is the times function in scope. We'll see. Lower byte is not in scope. Alright, so lower byte of an int. Need that. Huh, okay, so we do have some sort of gradient going on here. The top corner is red. And the screen recording just stopped for some reason. I don't know why. The top corner is red. And then the top right is red as well. That's curious. Is that intended? Not really. No.
I don't know why the screen is not
updating. Oh, it is. Oh, just very, very slowly for some reason. Why? Okay. Yeah, I don't get that one. Why's the red one always FF? Is that maybe the alpha one? Oh, hang on. In the plum thing in the array, when we say please get the thing at this point, oh yeah, that's not an item like the Rust version of that. That's still the plum native encoding. And what Zig does is it puts red in the first spot in memory. But our encoding in Plum actually puts, it sorts the struct fields alphabetically, so it puts red somewhere else. So this is actually just a pointer to, pointer to 0 to item.layout.size. Yeah, that's the one. And then that's what we want to return actually. So the item is item.from bytes of these bytes. unused local constant. Yeah, we want to return that. Nope, not like that. I want to rebuild the zig part. Okay, slice of single pointer item must have some bounds. Why is that a single pointer item? Oh, I think we have to do that. Expected type color, font size. Okay, so color from bytes should return you a color. That makes sense. Expected byte font int. All right. I mean, this is really, why would you not just use dot value? That's kind of weird, but I guess. Okay. It built, although with warnings. And now, oh, look at that. Yeah, in the X direction, we have increasing amounts of red, you know, from 0 to 5A. And at the Y direction, we have increasing amounts of green, again, from 0 to 5A, whatever 5A is. Alright, that's pretty cool. I like that. I like that a lot. So let's kind of increment that a bit further, because 5 is not super high. So let's instead do, I don't know, 30 maybe? Alright, let's say 25. Yeah. That should get us close to F, the maximum. Not quite, but yeah. Alright. Now let's try to render that. Let's try to render that. Oh, that's clean. Although, why is there segmentation fault? That's really, like, I have no idea why. Well, we'll find out sooner or later. Update your variables here, and that's kind of calculating the texture, I guess. You know. Then we begin drawing, and at the end of this loop we end the drawing. Okay, and then we clear the background. Now we want to draw the texture. So, oh, we have a lot of typed functions there. That's cool. Damn. There's quite a lot of stuff. Well, I think we want to actually, I think there's, let's look at the documentation, because I have heard that it's quite usable. All right, in here, raylib.com. And I'm just realizing the FPS of the recording is horrible. Let me maybe try to improve that. Okay, it's a bit better now. Not perfect, but well. Let's just read through this actually from top to bottom. I haven't done that yet. So Raylib is a simple, okay, and easy to use library to enjoy video games programming. Support the project, get the installer, okay. Okay.
minimalistic, that's okay, yeah. Cheat sheet, nice. The source code, an FAQ, wiki, examples, and games. Okay, let's look at the cheat sheet. Oh damn, that's quite a lot. So I think I want to create a sort of Raylib texture, then copy stuff over from my custom plum texture into the Raylib texture, and then say, Raylib, please render that. However that looks. So let's look for textures. Okay, so there is begin texture mode and end texture mode. That's promising, I think. Begin texture mode and end texture mode. Let's use that. Begin texture mode and then end texture mode. And this begin thing needs a render texture 2D with an ID and a texture and stuff. Okay, that's that's more complicated than I even need. Like, this texture has a depth map and stuff. Like, okay, there was shaders. Okay. And this is shape stuff. Okay, with lines and stuff. Our textures. Okay, this is interesting. This is interesting. Okay, we have images. Load image from texture and stuff like that. Okay. Load texture, okay. I mean, not quite. Load texture from image. I don't want to have an image though. I just want to create an empty texture. Now, how do I do that? Oh. Load render texture with a width and a height. That seems cool. That seems very cool. Load render texture. rl.load render texture with a width and a height. Look at that. Width and height. Yeah, we'll probably have to do int casts for those. Alright. Raylib texture is that. And then we can say begin texture mode of that Raylib texture. And then in here we draw something, right? Draw. Oh, we don't need to. We can just do this. Now this takes a texture 2D. Like, this looks perfect, honestly. rl.draw texture. Yeah, with a Raylib texture and then position, X and Y, and a color. That's exactly what I want. But this does need a texture 2D, which, how can you create that? Oh, there's also draw. Oh, I like that. I like that a lot. How do you create that? You can load it from image data. You can load it from a cube map. You can init it from a file name. Okay, maybe from image. And we can we somehow create an image maybe? Init, I don't know, with a file name. We can convert a texture from that, okay. Ah, gen color. Okay, that seems cool. Gen color with a width and a height. Image.gen color with a width and a height and a color, which we still need to figure out colors, you know. And that's going to give us a Raylib image. And then we can create that. We can create a texture. From the image. Nice. And then we can say well, we can say texture.draw at some x and y position, some color. Okay, and then we don't need this one, because then we can just do rl dot, if there's something like draw texture or something, draw texture. Does that draw into the texture, or does that draw the texture itself? I think I hope it draws the texture itself. Texture 2D. Yeah, draw a texture. But what is texture 2D? And how does that differ from the texture? Oh man. Why are they not, like, I want to see how the types are defined, not just the functions. The types are actually more important, right? Here we have colors, well. Oh, structs, here we go. Texture. Okay. So then what is texture 2D? Why does that not appear here? Come on. Like, this should be, first of all, this should be at the beginning of the documentation. You know, what does an image mean here? What does a texture mean? I mean, pixel data stored in CPU memory. Maybe that's actually better for our case. You know, we want images, I think, because our CPU, like Plum, doesn't have any sort of CPU functionality. So images are more fitting for that. So I think we do image dot draw pixel x, y, and color. Okay, yeah, you see, I like that. I like that. And then is there a draw image? No. Of course there isn't. Okay, we can create a texture from an image though. And then we can draw the texture. But that is a texture 2D. Oh man. And no tint, I guess? I don't know. Okay. Yeah, regarding colors, let's say look at that. Oh, and there were some defaults. I like that. Let's go with beige, I guess. And let's not even touch the plum texture for now. Let's just say we create an image. And the pixel at position 1, 1, that's going to be white. Okay. And then we begin drawing. We clear the background with, let's say, yellow. No, we can just do that, right? Oh, that's cool. And again, I'm not sure that works. Standard yellow, sure. And then let's draw a texture at position 0, 0. With what tint? None, maybe? No tint? I don't know. Violet. Sure. Then draw some text with not light gray, but gray. I don't know. Red. I'm not confident at all that that works. Yeah, see that. Oh, I mean, that actually makes sense. This needs to be a variable so that we can mutate that down there. Sure. And that compiled for some reason. Let's see. Okay, I think that actually worked. Whoa. That's kind of crazy. That is quite cool. I mean, it's segfaulted, but apart from that, we have yellow stuff. We have. Can you draw a texture with a scaling or something like that? Look at that, there's extended with the texture. Oh yeah, this one's nice. With a scale. I like that. Draw texture X. Nice. With a position, which is supposed to be a vector 2. Oh, is that? Yes. With a position and a rotation, sure, and a scale, which is gonna be 5, I don't know.
There was texture, there was texture extended, there was texture pro. Man. You know, when you don't have overloading, so you need to make... Oh, hang on. Stuff doesn't... I have to say on Wayland the screen capturing is horrible. It is honestly horrible. Sorry about that. Yeah, let's reload the texture and see if things work out. Whoa, yeah, this is bigger now. We have lots of stuff in there. Yeah, this is violet though, the tint, sorry. Let's turn that transparent, I guess. Oh, no tint, you know. I guess we're just in it with zeros all the way. And the most important bit being the alpha being 0. Maybe that doesn't affect the drawing in any way. Nope, that just removes it. And maybe white. Ah, yeah. Cool. Building that here, running that over here. Yeah, beige with a white thingy in there. Okay, now we don't want the extended version either, we want the pro version. Oh god, this API, this is horrible. Oh man. Okay, so this takes rectangles. Sure. Okay. What are rectangles? They have x and y, and width and height. Okay, so this goes from 0, 0, width is float from int width, and height being, you know, float from int height. This is the source, yeah, the entirety of the image, of the texture. We're gonna paint that to, well, position 0, 0. Width is gonna be float from int screen width, and height is gonna be float from int of screen height, like that. Yeah, hang on, that doesn't need the origin, which is 0, 0, which I think is only relevant if you rotate stuff. Right, then recompile that. Let's see. Oh, it is rotated. Not quite what I want. Why is that rotated? Oh, because rotation is 5 degrees or something. Ah, right. Okay. Compiles. Whoa! That was nice. Let's remove the text in the front and... Huh. Yeah, let's maybe inline that as well. So kind of like this. What? Oh, right. Don't need to clear anything because we're overdrawing everything. And then this is really small, so I think we need to defer here. We just do begin drawing, we draw the texture, we end drawing. So actually the texture here is our buffer. Oh, that's amazing. That's honestly amazing. Okay. Okay. then what else? I see where we get segmentation faults. So here we are basically using the render lambda, and in doing so we consume the lambda. So we give, the lambda takes basically takes ownership of itself. So if we still want to keep that lambda around and call it afterwards, we need to actually dupe that before. So let's do that. So that would be app.render.dupe that lambda, so that we can call that repeatedly. Okay, still crashes. Well, right, because I didn't build that. Yay. Yeah, true. Plum 9222. Nope, don't. We want none of that. Just build that and run that. Oh, look at that. Look at that. It's doing its thing. It's rendering and rendering and rendering. You can see all the frames passing by. Okay, and now we can close that up, and we have lots and lots of memory leaks. Oh, actually not that many. Okay, yeah. So now let's actually try to display the plum bytes to the texture. So basically doing this, just instead of printing them to the screen, like here, we store them into the, not texture, because that's on the GPU, we store them into the image, which we are building right here on the CPU. So we are creating an image, and then we are basically taking the pixels from the texture and drawing them into this Raylib image at position x and y with the color.init with red, green, blue, and alpha. All of those need to be bytes. That matches our model quite well. So we have the color red, that's a byte that has a value. We have color green. We have color blue. And we have color alpha. And yeah, that's that. So we're basically copying the pixels over into the Raylib image, and basically transforming the memory layout and so on. By the way, turning that into Raylib colors. So we should be able, right? This needs int casts. We should be able to see a gradient. Let's see if that works. Those compile something. Whoa. Okay. Okay, that's quite cool. That is honestly super cool. These are individual pixels, well, 10 by 10 pixels, and then stretched to fill the whole window. But these are rendered in Plum. Amazing. That is amazing. What? Oh God, every single one of these textures leaks memory, I think. That's horrible. Yeah, what do we want to do? I guess first of all, let's fix the memory leaks, right? We don't want to leak memory every single frame for the entire texture. That sounds horrible. So, what can we improve? First of all, I think
this makes sense. You know, we are duping the lambda because we want to use that same lambda multiple times. And then in here, this input size, we pass ownership of that into the lambda, but again, that's just a simple struct containing two ints. That doesn't even heap allocate any memory. But this texture here, that's definitely, you know, like that is heap allocated by the Plum code. And the Plum code returns that to us, so we are responsible for freeing that. Which means, you know, we can print that, we can create this image, we can copy the texture over to the image, but then we should free the texture, or at least, you know, kind of drop that. So drop that texture, like so. Yeah. So let's see, texture does need a dupe function that takes a texture and just calls self.pixels.dupe, and it needs a drop function which calls self.pixels.drop, which needs an allocator, and that's a standard mem allocator. This returns void, this returns void, maybe? What does this return? Void, yeah. Alright. So dupe and drop. And this should okay, still memory leaks. Unfortunate, but that's just the way it is. Fair enough. Fair enough. So after all of this, you know what, let's, just for simplicity, let's say that in here we break out of the loop. Basically simulating we should close. And then that, oh, yeah, that is maybe a bit simpler to spot the memory leak. But that compiled before. Oh, I didn't compile it with a drop. I see. So we do need a function drop in the color. Sure. We can do that. I mean, that's in no op, but yeah. Color. Dropping a color doesn't do anything, but you can certainly do that. Member function expected 0 arguments, found 1. Okay, yeah, drop takes an allocator. Which we also don't care about. Okay, that compiles with warnings. Oh, okay, so there was stuff happening. And we have an invalid free. I think it's the wrong, kind of solution, or the added the wrong length. Yeah. Self.cells.drop. Hang on, that's an array, if I remember correctly. So yeah, and here, when we can create an array from bytes, we can convert that to bytes, we can dupe that, we can drop that. In that case, let's maybe move that to up here. You can get an element from there. That's just self.start that is self.start. That's an int, I see. Yeah, to usize, okay, and then plus an index, and plus the index here, okay, and then we do offset and allocation. That will be 16 for the reference count and the length, plus the raw index times the item layout stride size. That gives us a pointer, and then we can, you know, decode the item at that position. Duping that, fair enough, that's easy. Dropping that, well, that's actually not just. Oh, like this seems reasonable. You know, dropping the individual items. But then in here, this is not just 16 plus the length. There's 16 plus the length times the size, the stride size of the individual item, which is bigger in this case. And let's update that, compile that, run this. Okay. We leak memory. Okay, that's a different problem. I think after the break, yeah, this is actually here we want to drop the lambda. We could just call it, you know, without calling dupliform, and the lambda will kind of free itself. But I think we don't really need this. We need the solution there. We don't need the value, the return value of that. So we'll just drop that explicitly, like so. Self-closure 2 bytes. Yeah, that's 232. Yeah, that was an int, I think, or something like that. Oh, self.closure, yeah, that's just usize. Okay, sure. We can do that. That compiles. Let's try to run that. Whoa. No leaking memory. That's cool. So now that's not eagerly break out of the loop, but actually, you know, keep rendering stuff until the user exits the window. We are rendering the texture. A nice gradient. You can look at that, and it's like re-rendered every frame. Pretty cool. And then you close that up. Boom. And it gets closed, and no memory gets leaked. Now that is cool. That is super cool. Okay. Okay, I like that. Whoa. Nice. Now, what next? Let's make the texture a bit more high resolution. Yeah, actually, I'm fine with like pixelated graphics. I kind of like that retro style of UI. But this is, you know, like it can be bigger than that. Oh, also, I want to make the window resizable, and I think what would be really cool is, as you resize the window, you know, the inner code, that the Plum code renders more or less pixels depending on the actual size. That would be quite amazing. So how do I make windows resizable? Resize. Is window resized? Okay. There is toggle full screen. Interesting. There's okay, image resizing, I guess. Oh. And that's it. There was set window state with flags. Oh god. The moment you hear flags, you know. Oh, okay. set window. What was the flag? Set config flags. I think you can do that before, maybe, before creating the window, and then those flags might be used for the flags. Okay. Okay, so we have, oh, is window undecorated with a taskbar and stuff. Whoa. Oh, that's cool. That is super cool. Oh, you can make the mouse pass through. What? Amazing. Okay, let's window resizable. That's the one we want. You can make that in full screen also. That's quite cool. What was it? Resizable. Window resizable. That's gonna be true. And then we create the window. I hope that that automatically makes the window resizable. But let's see. We have. Oh, right. I need to recompile that. Makes sense. Makes sense. Boom. And now, oh, look at that. A resize handle thing. Oh, well. Yeah, that makes sense. Yeah, it is technically resizable. I see that. Cool. So how do we react to that? I know there was something, is window resized? But do we even need that? Is it, like, I just want to get the size, basically. Is window resized? Okay. There is set window min size and max size. Oh, that's pretty cool. Set window size. Dang. Oh yeah, and then get screen width and height. Yeah, sure. Alright, so I think these initial ones, I'm just going to hardcode them in here because they might be invalidated as soon as you resize the window. So I don't want to, you know, rely on them too much. And instead, I want to basically recalculate them every frame. So the screen width, which by the way, I think the canonical zig way is with underscores. Oh, I think there's not, yeah, I'm not writing idiomatic zig code all the time. This is just rl.get screen width. Same with the height. Alright, so we have screen width and height. And where do we use them? In here. Screen width and screen height. Let's maybe break that not up on multiple lines. Yo, that's a pro texture drawing, if I've ever seen one. Okay, let's see. Okay, some build ones. Oh, look at that. Look at how that resizes. Smooth. Well, not really smooth. It's lagging behind and stuff, but it does resize at least. Whoa, that's cool. Actually, I want to make that, I think I want that to start out as a square, and then you can, you know, adjust that as you like. Let's make that squarish, and Yeah, we do something with the app, so that's kind of useless. I think we don't want to print the pixels every single frame. Yeah, plus these, I think. Instead of just 10, let's say we take the screen width divided by, I don't know, 20. Something like that. Yeah, these should be U sizes, and these as well, I think. Yeah. U size is just the same type for that. Oh, well. Now I want that to start out as a square. Oh, look at that. Dang. And it automatically, look at that, it changes the number of pixels so that they are roughly squarish in size. Oh, what, that's so cool. Yeah, only green pixels here. What? Then as you add more and more, bam. Yeah, 60 times 40 or something. Things, well, they do become slower, but only marginally. Yo, that's cool. That is honestly cool. Wow. I like that. And if I close this up, then no memory leaked, everything is tidied up. Yo, that's cool. Let's commit that. So first of all, let's do this one. What's going on here? Oh, that's sure. Just removed comments. The zig fetch command. Interesting. I'm not sure I like that actually. Like this is, maybe that's a useful comment. Yeah, I think that's, I think I like that. Yeah, then let's say, you know, add graphics support. Or rather support graphics. Boom. And then in Plum, I will add a graphics module with a definition of colors and textures. Yeah, improving the generate matrix, sure. Converting stuff to bytes, and so on. Okay. Wow. So this is render gradient. Huh. A weird repeating gradient, but still. Oh, that's so cool. Yeah, I think that's actually it for this video. I added Raylib as a dependency. I have nice weird gradients, and yeah, see you in the next video.